Okay, so a short video here on how to factor using the difference of squares. So again, factoring is kind of the opposite of multiplying a polynomial out. In this case, this is a special scenario that has a nice little formula path to go along with, so that you can factor it, really by just identifying the components of it. So, just a quick review here to the left, the different square numbers. So, square numbers are numbers like, 1, which is 1 times 1, then you have 2 times 2, which is 4, 9, 3 times 3, 16, 4 times 4, so on and so forth. You should be fairly familiar with the ones up to 144, which is 12 squared, 169, 13 squared, 196, 14 squared, 225. Obviously, there's more. 256 is 16 squared, and you can get the rest of them just by using a calculator. But the ones that are most common are up to 15. So 1 through 15 are listed here. Also, if you have a variable, the variable square is any even exponent. So x squared is x times x. X to the fourth is x squared times x squared. X to the sixth is x to the third times x to the third. Because remember, you add the exponents. X to the fourth times x to the fourth gives you the 8. X to the fifth times x to the fifth would give you x to the 10th. So any even variable is going to be a perfect square as far as the breakdown of this. So as we're factoring with the difference of squares, you go through a checklist. Number one, if you have a greatest common factor, meaning all the terms of the polynomial have a value you can divide out, always take that out first. All right? Sometimes you have to take out the greatest common factor before you get into a difference of squares. Another thing, after you do that, number one requirement here for the difference of squares, you have to have a binomial. That means two terms. Third thing, it must be a difference. Remember, a difference is subtraction. Okay, so you're subtracting the two values in the binomial. And both terms then must be perfect squares. So the process of doing this factoring method. All right, so in this example, I'm just using arbitrary numbers a squared, b squared. We'll get to a more specific numerical example next. But obviously we have a binomial. There are two terms there, a squared, b squared. The second requirement must be a difference, which it is because we do have subtraction here in the middle. All right, so we have a binomial, we are subtracting, and we have two things that are perfect squares, because just like x squared is x times x, these are going to be a times a and b times b. So when you put these into the factored out set of parentheses, what you're going to do is you're going to take this first value, you're going to take the square root, you're going to write it in the first part of each parenthesis. Then you're going to take the second value, and you're going to take the square root of that one, which would be b times b, and that's going to go in the second part. And then, kind of think of the word difference as the word different. You're going to put different signs, so a plus sign and a minus sign. And that would be the factored out answer. Okay, so not something that's overly complex. You just got to be able to identify perfect squares. All right, so let's go through a second example. So if we have x squared minus 25. So again, our goal is to factor it as a product of binomials. We have two terms, x squared and 25. So it is a binomial. We have a difference because there's a minus sign. And now we look. X squared, can we take the square root? Yes, we can. X times x. Then we look at the 25. Can we take the square root? We can. 5 times 5. And then we're going to place a plus sign and a minus sign. And why that factors that way? If we did FOIL this to check, if we did x times x, that's x squared. Then we would do the outside, which would be negative 5x. Then the inside would be positive 5x. So the negative 5x and the positive 5x cancel out. That's why there's no middle term. And then 5 times negative 5 is 25. and it's a negative. So that's, again, you can always check your results that way. Okay, so if we go through another example here, let's say 4x to the second power minus 49. All right, so again, the goal is to factor them as a set of binomials. We have a binomial, we have two terms, we have a difference. We look at perfect squares. Can you take the square root of, we know the x is x times x, but now the square root of 4 is 2 times 2. So instead of x times x, it's 2x times 2x. We look at the second term. That's 7 times 7. We put a plus sign, we put a minus sign, and we are factored. If we have the example of, let's come up with one here, say 9x to the sixth power minus 16, oops, I don't want x, let's do a different letter, 16y to the second power. So again, we have a binomial, we have two terms, we have a difference, now we check perfect squares. So x to the sixth is really x to the third, x to the third. 9 is really 3 times 3. So 3x to the third times 3x to the third gives you the 9x to the sixth. Right here we have a y and a y, because y squared, square root is y times y. And then the 16 would be a 4 and a 4. Put a plus, put a minus. The end. Two more examples here that we're going to go through. So the first one, let's say 3x to the fourth power minus 27. So first things first, greatest common factor. So we take out the 3, divide the 3 out. So now we have x to the fourth minus 9. Now we have a binomial that has perfect squares, because right here, this 3x to the fourth, you can't get a perfect square. You can't take the square root of 3. But now after we took the 3 out, now that's going to work. So square root of x to the fourth is 2 and 2. Square root of 9 is 3 times 3. We're going to put a plus sign, we're going to put a minus sign, and then you just got to make sure you bring down the 3 that you factored out. Okay, so that's an example if you have a greatest common factor. Okay, last one, let's say 4x to the second plus 25. So on this one, so we go through our checklist. Binomial, we do have a binomial. We can take the square root of this, that's 2x times 2x. The square root of 25 is 5 times 5, but one of those check boxes is not satisfied. This is not a difference. So this one is prime, or you could say not factorable. So that'll cover the first part of this week's lesson with the factoring of difference of squares. Look for a second series of factoring methods that we'll do kind of later on throughout the week.